Good morning, everyone, or I guess evening if you're watching this right now, and if it's live. Hi, my name's Jackie. Welcome to my Introduction to Docker workshop. Today's workshop is going to be covering TLDR, what the hell Docker is, and why everyone seems to want to use it so much. Before we get started, brief introduction about who I am. Hi, my name is Jackie. As I said earlier, I'm currently a second year CS student at UBC. In my spare time, I enjoy rock climbing, reading, and organizing hackathons. Some of you actually may have been at NW Hacks this last weekend too. Yeah. Also, you can follow me on GitHub or Twitter to see some of my lukewarm takes and questionable code as well. Enough of the self-plug, a little bit more about the actual workshop itself. So the first 5 minutes is just going to be a brief introduction about what Docker is, what containers are, and why anyone would ever use Docker. Don't worry if all of this terminology is kind of flying over your head right now. We'll cover it a bit more in depth when we get to this part. The second part is the different parts and the terminology that comes along with using Docker. So like what the hell a container is, an image and a layer and a Dockerfile. Like we'll all talk about kind of how that works and how that fits together when you are working with Docker when we get to that part. After that, we'll be diving briefly into the Docker CLI, so how you as a user can interact with Docker and what a typical Docker workflow would look like. Following that, we'll be Dockerizing a simple Node Express application just to kind of walk you through what a real-world example would kind of look like, and then finally deploying that on Google Cloud Run. So before we actually get started, we have a few prerequisites that we kind of assume that you went through before the start of this workshop. The first of which is we kind of assume that you've gone through the pre-workshop checklist. As this is an intermediate workshop, the expectations are that you're kind of familiar with some of the more basic things like how to use a CLI, and just kind of generally recommended for you to have a good time at this workshop. First of which is hopefully you have Docker installed at this point, so you can follow along. And the second and third points, knowing basic Node.js and having a Cloud CLI installed, they're more optional. We're going to be Dockerizing a Node application near the tail end of the workshop, like I mentioned earlier, and if you would like to follow along, it would be beneficial for you to have those. Last but not least, I do have a GitHub repository set up for a lot of the stuff that we'll be covering on today's content, so if you want, please visit that link. It will contain a lot of the base code that we'll be using for our Node application later as well. So starting off, what is Docker? That's kind of like the titular thing that we're talking about during this workshop. TLDR, Docker is a tool that makes it really easy to package applications into containers. You may notice eventually that I'll start doing some like recursive definitions. I'll talk about containers, but I haven't defined containers yet, but I will get to that on the next slide. So Docker containers, when you first think about the word container, a Docker container isn't the first thing that comes to your mind, right? A container in general is just anything that can contain something, right? Containers, in a sense, are self-sustaining. They contain everything that they need in order to do something. In the case of Docker, this is a software such as libraries, dependencies, and source code. So why would anyone ever want to use Docker? Docker also isn't the only tool available on the web to work with containers. There's a lot of other ones like Mesos, Containerd, but why would anyone ever use Docker? Specifically because Docker is decently easy to use compared to some of the other tooling. You can use the Docker CLI, which is pretty easy to use, and there's a lot of support around it, especially within the community. So when you have a problem with Docker, it's most likely already been answered on Stack Overflow already. Second of all, it allows you to programmatically define containers. So you can define containers through Docker files, which you can collaborate on and work on as if they were actually code. So you can apply version control like Git to work with other people on containers, which is really nice. So if all of that little previous bit was a little bit confusing, don't worry. We'll be taking a closer look at some of that terminology that we talked about earlier and apply it to Docker, specifically through the lens of an IKEA analogy. You can kind of think of IKEA, Docker as an IKEA store. They both put together and store packages that are fully self-contained. In the case of IKEA, these packages are pieces of furniture that you pick up in the showroom. But in Docker, these are pieces of software that are fully packaged and ready to go. So in a Docker container is a fully self-contained and running version of your application. all of the pieces that were once inside of this container are now outside and fully assembled into a thing that can be actually used and is currently being used. In the case of IKEA, this is when you've taken out everything out of your box, you put it together, and you have a fully assembled piece of furniture that you can use. A Docker image, on the other hand, is a template that describes to Docker how to create a container from scratch. So this is the actual box containing all the pieces of IKEA furniture that you haul in the back of a U-Haul to your dorm. And it's the box that has all the pieces of furniture along with all the necessary tools like screws, hammers, and like the twirly thing that you get in the IKEA package and whatnot to kind of fully assemble it. So yeah, the image is like the package containing all of the pieces that you need in order to fully assemble a piece of furniture. So a Docker layer. Docker, much like onions or ogres, have multiple layers. Layers are reusable components that can be shared across images. In applying this to the IKEA analogy, you can kind of think of Docker layers as reusable pieces across different pieces of furniture. Like for example, those like wooden peg things that is in like pretty much every IKEA piece of furniture that you can find. Now that is a common component that can be reused. It's the same thing that you can find in like all the different pieces of furniture. So TLDR, yeah, a Docker layer is a common component that you can find across different pieces of IKEA furniture. Last but not least is the Dockerfile. This is the actual instruction manual that Docker actually uses to figure out how to build your image. This is the only part that you as a user need to manually write yourself. As it applies to the IKEA analogy, this is the kind of manufacturer's guide that tells IKEA how to actually put together the packages and telling IKEA exactly what materials they need to put in each package and in what order to package it in. TLDR, if you're more of a visual learner, this is kind of how things kind of are assembled together and how they fit together. The first of all is the Dockerfile, right? The Dockerfile is the instructions for how to build the image. This is the manufacturer's guide. So IKEA takes this and starts assembling pieces of ready-to-go like packaged furniture. This is the Docker image. So each Docker image contains everything you need in order to create a piece of furniture or a piece of software, right? And then we can create a piece of furniture from a Docker image by following the instructions inside. And finally, assembling all the pieces together into a Docker container, which in the case of the IKEA analogy is once again like the fully built piece of furniture. Yeah, so to reiterate as it applies to the IKEA analogy, the Dockerfile is a manufacturer's guide for IKEA. The Docker image is the piece of IKEA furniture that you pick up from the IKEA showroom, and the Docker container is the actual fully assembled piece of IKEA furniture. So before we get more into the Docker CLI, I'm going to do a brief break here just so everyone can kind of catch up and clear any pieces of understanding that they may be a little bit fuzzy on. There's a bunch of workshop TAs here to help out as well. So if you have any questions at any point, feel free to message in the Hopin chat. We'll try to answer your questions the best we can, and we'll take a brief 3 to 5 minute break right here. Oh yeah, also as a brief reminder, now would be a really good time to check if your Docker installation actually works. So now would be, you can pull up your favorite terminal of choice and kind of follow along as we run some of these commands. I'm also going to do that right now. Pull up my iTerm and zoom in a little bit just so everyone can kind of see more clearly what I'm typing. Hopefully that's big enough for everyone. And yeah, first of all, run Docker, run hello world. This is just the basic check to make sure that you have everything working. And once you do that, you should see this hello message that tells you that everything is working. If you're unable to run this command or able to get something to show, reach out for a TA for help right now. Okay, moving on. Yeah, so now we're gonna get a little bit more hands-on. Make sure you have Docker installed if you haven't already. Also, at this point, if you haven't already, make sure you've cloned the Docker explained repository and have navigated to the basic node folder. So I'm gonna also follow along with this on VS Code so I can kind of show you as well. But I'm gonna file, open recent, Docker explain. You can find the link to this in the pre-workshop checklist, as well as at the start of this PowerPoint slide. But I will zoom in and hopefully you can see what I'm kind of typing here. Yeah. You may remember earlier that how do I turn a Docker file into an actual image. So we're gonna be a little bit more hands-on how to actually work with Docker right now. And you may remember that Dockerfile is the only thing that you as a user needs to write, right? How do we turn this Dockerfile, so this manufacturer's guide, into an actual usable image that Docker recognizes? So that's what the Docker build command is for. Briefly explaining what this syntax kind of is doing right here. So it's telling Docker to build and look for the Docker file in the current directory. That's what the dot is for. And then tag the result with this name and this version. So we're telling Docker to create an image called node example with the version tag latest by looking for a Docker file in the current directory. So if we navigate to Docker explained, and then to node, to basic node, right? Show you that I have these files right here. We have a Docker file in the current directory, right? So we'll execute this command and then build our example image. So Docker build in the current directory and then tag it with the name. Let's call it node example and then the version latest. If everything is set up correctly, you should see Docker working through and building it step by step. Each step is an individual Docker layer. But yeah, you should hopefully see a successful build message, successfully tagged node example latest. So we'll know that Docker successfully built our image and added a tag to it. Next up, you may want to know, okay, now that I've built my image, how do I see a catalog of all the images I've built already? You do this through a Docker image ls. So what this does is tells Docker to list all of the images it knows about, as long as some example, like some handy stats, like for example, the tag that it got tagged with, the image ID, when it was created, and the size of the actual image. So if I were to do that right now, Docker image ls, this is a bit funky just because my font size is whack, but you'll see that we built this node example tag latest, right? Something we just built 47 seconds ago. I have a bit more garbage down here, but yours should at least contain this first entry right here. Okay, so now that I have this actual image, how do I turn this into a running example? So you may notice earlier that if we go back to this basic node, right, we have an app.js, right? So I'll go back to my VS Code. What this is, it's a basic Express application. That's just kind of like a simple hello world. And it just says hello world if you visit localhost, right? And if we want to run this, you should do npm I to install the dependencies first. I've done that already, but do that if you haven't already done that. And then do npm start to start the local example. Then we can visit this on our local browser, right? 3000 and get a hello world example. So this lets us know that we have our application working. So you may recall earlier that we Dockerized this, right? So now we have this inside of a Docker container. How do we get it running so that it also serves a hello world on our local machine too? That's exactly what Docker run is for. We can go from a container to an actual image. In this case, you also have to note that containers are by default sandboxed from the rest of your computer. This means by default, Docker doesn't know how to interact with your local machine's network. So we need to tell Docker exactly which ports that our application needs. So we can tell Docker to map our localhost machine's port 3000 to our containers port 3000. And this is how we run that. So I'm going to show you what it looks like if we run it without the port forward first. So we just do Docker run, right? And then the name of our image, and then the version. So we'll see doing that, and then we'll see that starting message that we saw earlier. So example running localhost 3000. If we go back to our web browser, reload it, oh, we can't reach the site. And this is exactly because the port 3000 on the container is not connected to our local machine's port 3000. And that's why we need the -p flag. So if we do -p, right, and then we map our localhost 3000 to our container's port 3000, then the port should be mapped correctly. And if we go back to browser and refresh, we should get a hello world. Yeah, there's a lot more information about that if you want to look at it more in the Docker documentation. Docker documentation itself is pretty comprehensive. So if you are stuck about what to do at any point, make sure you search it up on the Docker documentation. Okay, so now that I have a container running, I want to make sure that I don't have any port collisions or whatever, or the things I'm running right now need to be running. Docker is pretty notorious for eating up your resources, so it's good to kind of have like a task manager to figure out what's using a lot of your resources and kill them as necessary. So normally you would do that on your local machine through something called the PS command, which is the process status. And you can do that similarly with Docker as well. So now that we have this running, I'm going to open a new pane and then do Docker PS, and then this will list out all of the, okay, maybe I should just make this a tab instead. Uh-oh. Okay, yeah. So you may have noticed, if I expand this out, that this shows all the processes that are currently running right now. We have the first one, which was never port forwarded, that we ran earlier, and then the most recent one, which is the one that we have running right now, this one. And you can see that it's port forwarding from localhost 3000 to the machine's port 3000. And it gives you some pretty good stats about when it was first started and when the image was actually created. So if we want to terminate these, conveniently Docker PS gives us the container ID, and we can reference this container ID to kill it. So we can do Docker kill. I'll zoom in a bit more so you can see more clearly. Docker kill, name of the container, and then it'll return you the ID of the container if it killed it correctly. If we do Docker PS again, you can see there's only one left. Let's kill this one as well. And if we run Docker PS one more time, all of the containers should be killed, and this gives you an empty result, meaning that there's no more containers running. So if a container isn't working, is there any way I can actually debug it myself? Normally on your computer, you would use something like top, or just look at some configs on your computer, or just open up the folder on your actual machine. But how do you do that with a container? Luckily, there's a command called exec that lets us do exactly what we need to do, which is execute commands inside of a container. The only thing that we need to know is the ID of the container we want to run it inside of. Let me just give you a brief example. Let's run our node example one more time. So we have it running. And if we do Docker PS, you can see that we have this container that's up right now. And then we can get this container ID right here and then execute commands on it, right? So all we need to do is provide Docker exec and then the name of the ID and then the command you want to run. This -it flag tells Docker to run it in interactive mode. So if you run a shell, for example, it will allow you to keep inputting commands rather than just only executing the one that you enter. So if we do Docker exec -it, name of the container, and then the command. So in this case, let's do a simple echo command just to say hello world. This is saying hello world from inside of the container itself. If you want to actually run the shell, you can do /bin bash, and then we're actually now effectively inside of the container. And from within the container, we can do top, for example, to list all of the running processes. We can see that only the node command and the current bash top command that we're running right now are the only things running on the machine. You can also, for example, list everything. You can see that all the contents of the Docker container and whatnot. And it's pretty handy to debug stuff this way too. So you want to do nano.app.js. Okay, there's no nano, but cat out the output and then see the contents and whatnot. And to get out, we can just type exit. Okay, so now you may be wondering, now that I've seen all this kind of how to work with Docker, how do I go about making my own containers? So this next part, we're gonna kind of walk you through how to actually write a Dockerfile and then Dockerize the Node.js application we were looking at earlier, and then getting it deployed on Google Cloud Run. I'm gonna give you all another 3 to 5 minute break just to catch up if you haven't already and ask any more questions you may have. Okay, I'm gonna continue on ahead, but this is the recording. Just skip ahead like 5 minutes, or pause for 5 minutes, sorry. Okay, starting off, we have this app.js that we saw earlier, right? It's just a pretty simple Express application. It serves some images and whatnot, but why would we ever want to Dockerize a Node application? At this point, I would be taking questions from the audience, but because there is no audience, I will fake some questions, fake some answers. The first of which is, you could say we want to increase reproducibility. Because Docker packages all of your dependencies together, you never need to worry about, it works on my machine, why doesn't it work on your machine? Because all of the packages and dependencies are already contained inside the container itself. So you never need to worry about that, usually. Second of all is ease of deployment. Because all of the packages and dependencies are contained, launching a Docker container containing a Python application versus launching a Docker container with a Node application is exactly the same process. That means no matter what your source code is, it's the same way of running it, which makes it really easy to deploy on cloud providers like Amazon Azure, Microsoft Azure, Amazon AWS, and Google Cloud Platform. So all of those all have really good support for running Docker containers, but throughout this example, I will be using Google Cloud Run. I'll explain what that is in a second. But yeah, TLDR, you want to Dockerize an application, first of all, to make sure it's reproducible across different machines, right? So if it should be the same across your development environment, production, and like staging environments, whatever, and Docker is really good for that. Second of all is it makes it really easy to deploy places. And it also has an advantage over virtual machines in the sense that virtual machines require you to load the entire operating system, whereas Docker containers run on your operating system, but only contains the things it needs to run. I'll talk a little bit more about Docker versus VMs. If anyone ever has more questions about that, feel free to message me about it. But yeah, so I will briefly walk over what the Dockerfile actually looks like in VS Code. So let's over to VS Code, open up the Dockerfile. I mentioned earlier that each line of a Dockerfile is a layer. So these are all reusable components that you can find within Docker files. This first layer pretty much is the base layer. This is what provides the main base functionality. So Docker provides some handy base images like Node and I think Go as well, and Python based images that come with everything you need already installed for you to be able to run a basic Node application. So this Node base image comes installed with npm and Node as well, so you don't need to install those manually. If you want to find more of these yourself, you can go to Docker Hub, and then, for example, Node base image. So the Docker Hub contains, it's kind of like a GitHub for Docker images. You can basically use any of these as a base image to provide some functionality. So yeah, Node.js is blah, blah, blah. It's a way of running backend JavaScript without a browser. And yeah, kind of briefly telling you how to use this image, what the image does, and whatever. But all you need to know is that this base image provides the base functionality we need to run a Node application. Now the second step is more of a best practice thing than anything. Usually you want to have a directory that's not directly in root that contains all of your source code. So in this case, I'm going to create a folder called /user/src/app. What workdir does is it's a combination of make directory and change directory. So it'll set your current directory to whatever this folder is, and if this folder doesn't exist, it will create it for you. Next, we want to install over all of our Node applications dependencies. So what we do is we copy over the package and the package lock.json, which basically just tells Node, hey, here's what dependencies I require and what version I need them to be at. So we'll copy those from our local machine, right, our current directory, into our current working directory in the container, which as of now is /user/src/app. After we copy over the app dependencies, we then want to install the actual dependencies themselves using npm install. This will once again execute in the current working directory, which is this folder. Now, this combination of 3 layers is before we copy over the source code. You may find this interesting because you would most likely tell yourself, okay, why don't we just comment this out, copy the source code right away, and then run npm install? Like, why don't we do this? Does anyone have any idea why we want to do this instead of just copying it and running install? I'm gonna assume people answered, but TLDR, Docker has layer caching. So whenever a layer is edited, so for example, your local files that are being copied are edited, it will invalidate all of these layers and need to rebuild them. But everything above it remains cached because it didn't change, right? So what this is saying is that every time you change a file on your local machine, you have to reinstall the dependencies every time, which is not ideal, right? So if we comment this out and then examine more closely what this kind of does, this is saying that copy over the package.json right away, and only if the dependencies change, then reinstall the dependencies. If you change the source code without changing the dependencies, these layers still get cached, so you don't have to rerun it. This allows for faster iteration times when you're developing with Docker containers. Obviously, the previous one also works, but this is more of just like a quality of life kind of thing that allows you to develop Docker containers faster. Last but not least, we have this command thing. This tells Docker how to actually run, what's the entry point into your Docker container, what command should I actually run when I say Docker run. And in this case, it is node app.js. You just want to start the app.js application, and we do that by providing an array of all the commands. So this is the equivalent of running just node app.js. It's just space separated into an array for some reason. But yeah, TLDR, this is a basic Docker image for Node.js. Inside the repository, you can find some more advanced ones for Python, which is actually a lot simpler, and Go, which is more of a compiled language, so there's some more complex stuff in there. But if you're more interested in some of those, feel free to peek around in the repository as well. If you have any more questions about some more advanced languages, like building on Rust, for example, you can feel free to DM me afterwards as well. But yeah, so now that we've kind of figured out how to write this Dockerfile, how do we deploy it on Google Cloud Run? Luckily for us, Google Cloud Run makes it super dead easy to run containers on the web. The benefits of using Google, okay, just to preface, I'm a really big Cloud Run advocate. First of all, because it is super cost friendly. Google Cloud Run gives you 50 free hours just to run whatever container you want every month. And the nice thing about Google Cloud Run is that it follows like a serverless architecture. So it manages all of the scaling and actual server stuff for you. The only thing you need to worry about is uploading your containers. And what this means is that if you don't get any traffic, Google Cloud Run will not actually have any instances of your application running. So you won't be charged for it. The only time you'll get charged is when someone actually accesses your application. Google Cloud Run will spin up a container, serve the request, and then spin it back down. Just for reference, I get charged maybe like 4 or 5 cents for like the 4 different things I'm running on Google Cloud Run right now. So it's definitely pretty affordable to run things on Google Cloud Run. Second of all, it's really easy to roll out new revisions using Google Cloud builds. For the sake of this tutorial, we're not going to be setting this up, but if you want to set up a good CI/CD workflow, Google Cloud builds allow you to listen to like a GitHub repository, for example. So when things change, it'll automatically build and push out a new image to deploy. Third of all, Google Cloud Run is highly available. Because everything runs on Docker containers, usually containers spin up very, very fast. So you can serve a request from a cold start in less than 100 milliseconds most of the time, which is pretty close to negligible. Last but not least, this is more of a personal preference thing. Google Cloud Run enforces stateless backends. Because Google Cloud Run containers spin down after a certain amount of time, there's no way you can actually store things in memory. You might be able to cache things in memory, but most of your user data storage should be happening through a database like Mongo or SQL or Postgres, and kind of enforces best practice in that sense. So enough talking. Let's get started into kind of figuring out how we want to deploy on Google Cloud Run. Before we do that, please make sure that you have Google Cloud CLI installed already. So if you haven't already, run gcloud. Sorry, I can't type. Gcloud. And if it gives you this help menu, then you know you have it installed. So if you haven't already, install gcloud, the Google Cloud CLI. Instructions for how to do this are in the hack pack for this workshop as well, if you haven't seen it already. I will check back in another 3 to 5 minutes just to make sure everyone has this and is ready to go. But yeah. Okay, at this point, I'm going to pretend that 5 minutes has elapsed, and then jump back into the actual presentation. So the first thing I want to do is search up Google Cloud Run. The first result kind of tells you a TLDR of what Google Cloud Run is. But yeah, you'll first want to go to console. And then at this point, you'll be brought to the Google Cloud Platform, like main console, and then you want to create a new project here. So select this drop-down menu right here. Click New Project, and then name this. So right now, I'm going to call this HTN Docker Workshop, dry run, or I guess recording in this case, and then click Create. So it's going to take a few moments just to create our actual project, and once this is done spinning, we can select that. So I click Select Project right here, and now we should be inside Hack North Docker Workshop recording. So at this point, we want to create a new service. So each service is an instance of a type of Docker container, like a Docker container that you give to Google Cloud Run to deploy for you. So while we wait for the Cloud Run API to be enabled, we need to figure out, okay, how does Google Cloud Run figure out where my containers are stored? Luckily for us, Google Cloud Run has a container registry that we can use. So you can kind of think about this as like a GitHub repository for your Docker containers. So if you go to container registry, we need to figure out how we want to actually push images there. So when you're setting up your Google Cloud CLI thing, it should have prompted you to figure out how to link your Google Cloud CLI to the actual Google Cloud Platform account, right? And in doing so, this should help you authenticate any pushes to Docker Cloud Run. So I actually wrote myself a little handy guide, I think. Okay, I did not. It's in README, I think. But yeah, at the bottom, deploying on Google Cloud Run. The only thing we really need to do is tag our image, our local image, with the Google Cloud Run repository. So gcr.io, which is the repository, the domain for Google Cloud Run, the name of our project, and the name of the image along with the version. So if we do docker tag, right? So this tags an existing image. So we notice we had node example latest before, right? We want to give it a new name. So gcr.io slash project name. So our project name is this right here. So you can copy the ID. And then after you've done that, give it a name. So I'm just going to use the same name, but this can technically be different from what you had before as well. So we do that. Now we can see that we've successfully tagged it if it didn't give us any errors. And then if we do once again docker image ls, we should see that the image is tagged and also inside our image ls. So if we go back to create service, okay, this is still spinning. So in the meanwhile, I'm just going to go up and push this image that we built earlier onto Google Container Registry. So we can do docker push and then the tag of the image. So because I'm lazy, I don't want to type this out. I'm just going to select the name and paste it. And basically, it's docker push and then your image along with the version, so latest. And then once you do that, this will now push all of your layers onto Google Container Registry. And yeah, so we'll wait slowly kind of while it works its magic and pushes everything to Container Registry. Okay, so once we get this digest, we should note that now GCR has our image. So if we go back to GCR, we should reload this page and hopefully we should find our image there. Yeah, so wonderfully we have our node example image right here, and then we can look at it and we saw that we created it 25 minutes ago, but we just pushed it now. So if we go back to Google Cloud Run, okay, we can see that it's finally been enabled. So we want to select a region. Usually I just go with US West just because it's the easiest to set up. And then give it a name. So let's call it node example. Oh, can't spell. Node example. Next. And then Docker container URL. So we can do is select, right? And then this will look at our Google Container Registry, and then we can, oh look, this is the image that we just uploaded. And then select the latest version and click select. And this will just basically tell Google Cloud Run, okay, just use the image I pushed up just recently. If you wanted to set up Google, container builds, you would select this one, drop down right here, and then set up cloud build right here. But for the sake of this workshop, we're going to keep it simple and just use an image URL from Container Registry. Click next, and then we can configure some things. The first of all, which is an ingress. So this is just basically allows you to manage incoming traffic. Right now, we don't need to worry too much about it. We just kind of want to test our node application. So we'll just click allow all traffic for right now. And the second part is we want to allow anyone to be able to hit our endpoint, right? We don't, right now, we don't want to restrict it to only people who are authenticated, just for the sake of testing. Obviously, if you're developing production level stuff, you probably want to require some sort of authentication, but we're not going to worry about for the sake of this workshop. So we're going to want to click create. And then Google Cloud Run will now spin up all of our containers really nicely for us. So now we'll wait for another 3 minutes really quickly just to wait for this to spin up. If at any point you kind of got lost during this process, reach out to a TA for help, or yeah, just send any questions you have in the chat too, and I'll be happy to answer them. One more brief thing I'm going to mention. Google Cloud Run does set a port environmental variable that you should be listening on. So what I'm doing here right now is saying that check to see if there's an environmental variable called port available. So if there is, use that value. Otherwise, default to port 3000. Most likely, I think Cloud Run just provides you a random port, and then it'll just tell your application to listen on that. So that's usually what happens. But yeah, if you're using any other language, you do need to do this part as well. Make sure that you listen on the environmental variable like port. Otherwise, Google Cloud Run will complain. Okay, we see that now. Okay, nice. We have our node example running. We can visit the URL to see our hello world. So yeah, now we've successfully deployed our container to the cloud, and that pretty much wraps up the entire process from writing a Docker image, a Docker file, building an image, creating a running container, and deploying that container to Google Cloud Run. As a reward, I'm gonna visit /doggo just to get a nice dog picture. But yeah, thank you everyone for being so patient and sitting along with this workshop. I hope you learned a thing or two about Docker and found something that you can apply to your hackathon projects or even beyond. And best of luck and happy hacking to everyone. I will be sticking around for questions, so if you do have any questions, feel free to message me in the chat, and TAs will also be around to help as well. But yeah, thank you everyone.